Hello and welcome to Maths by SAS. This is my sixth lesson of D3, chapter number 8, exercise 8C, that is about the application of sine law. If we recall the previous lesson, we can understand it well that sine law is used for the solution of oblique triangles, for finding lengths and angles of oblique triangles. For the solution of right angle triangle, we have two techniques with us. One is the Pythagoras theorem and one is basic trigonometric ratios. So before going to the lesson, your mind has to be really clear that for solution of non-right or oblique triangles, we are not going to apply Pythagoras theorem. We will be preferably using sine law or cosine law. Cosine law I will be teaching in the next class. Let me move to the actual lesson of today's class. I'll start my class with question number 6, and it's really important to read the question before the solution and compare the data, and if there is some mistake you can correct it in the beginning. Question says, in triangle ABC, angle ABC is 91 degree, BC length is 7.4 centimeter, AC is 11.6 centimeter, and we have to find angle BAC. BAC, this is the requirement of question. ACB, this is the requirement of question, and length AB. Okay, it's always good to sketch the figure. So I've drawn the figure for you people, and we know that the vertices or angles must be marked with the capital letters and their corresponding lengths must be marked with small letters. As this is the vertex C, so the opposite length will be C, and this is A, so it will be small a, and this is B, so this will be small b. Okay, now we have to write the basic sine law, that in triangle ABC, A upon sine of A, okay, the length will be divided by its corresponding angle. Sine A equals to B upon sine B equals to C upon sine C. Now what we have to do, we just have to replace the values carefully. That A has the value 7.4 upon sine A, because angle A is not known, that is the requirement of question, and B, side B is 11.6, and then I have to divide it with sine 91 degrees and equals to C unknown, okay, and the angle of C as well is unknown, sine of C. Okay, after writing the equation, we can see that over here we are given with the three values and one unknown we have. So in the beginning, in order to get the angle A, we will be equating sine 7.4 upon sine of A by 11.6 upon sine 91. So in the beginning, I'll be taking this portion of this equation, and the question will take the form 7.4 upon sine of A equals to 11.6 sine 91 degrees. Okay, now what we have to do, I have to find the value of sine 91 with calculator. Sine 91, so this is 0.9999 and 8. 7.4 upon sine of A equals to 11.6 into sine 91 is 0.12399 and 8. Now go for cross multiplication. That's 7.4 multiplied by 0.998 equals to 11.6 multiplied by sine A. Now get the product of 7.4 and 0.998, and this gives me 7.39852, okay, and equals to 11.6 into sine of A. Now shift this 11.6 to other side and divide 7.39852 by 11.6. I can write my equation in this way: 7.39852 upon 11.6. 7.39852 divided by 11.6, and this gives me sine of A equals to 0.636378 and 0. So I will write 6378, and A equals to sine inverse of 0.6378. Now I have to press the shift key, then sign key, and display will have sine inverse, and then I have to write the value 0.6378, and this gives me angle A equals to 39.627, 39.6 and degrees. And let me block this answer. Let me block the answer. A equals to 39.6. Okay, and now I have to replace the value over here as well, that angle A is 39.6 degrees. And now for the calculation of angle C, what we have to do, we can see, we know that the sum of interior angles of triangle is 180 degrees. Now 91 plus 39.6, 39.6 plus angle C equals to 180 degrees, and 91 plus 39.6, 91 plus 39.6 gives me 130.6, 9 and 110, yes, 130.6 plus angle C, or angle C equals to 180 minus 130.6. Okay, I have to take away this answer from 180, and this is 49.4, 49.4 degrees. Okay, and then I have to write the value of angle C over here, that this is 49.4 degrees. Okay, let me check my calculation again. That 91 plus 39.6 is 130.6, and I have to take it away from 180 degrees, and this gives me 49.4, 49.4 plus 39.6 plus 91, and this is 180 degrees. Okay, it means that my calculation for angles is correct. And now let's quickly move to the second unknown of the question, that is the length C. Now we have angle C with us, so what we will be doing, that 7.4 upon 11.6 upon sine 91 degrees is equal to C length, which is unknown, upon sine 49.4. Now we can see that we have the value of sine 91 already with us, 11.6 upon 0.9998, and sine 49.4. Sine 49.4 gives me C upon 0.7592793. Now what we have to do, we have to divide 11.6 divided by 0.9998. This gives me 11.60. 11.6 equals to C upon 0.7593. Multiply 11.6 by 0.7593, and this gives me C equals to 11.6 multiplied by 0.7593 equals to C or C equals to 8.807, and that is 8.81, and the measurements are in centimeters, so I have to write centimeters. I hope you are clear that how we are finding the unknown lengths and unknown angles of this question. You can see that two angles were unknown. The first angle we have calculated with the help of sine law, and for the calculation of second angle we are going with sum of interior angles of triangle, and for the second length we are making use of this part of the question where both the numerator and denominator are already known. We are not trying to involve those calculations that we have done because they can have some error, and error in one part can cause error in the other part as well. So please avoid such errors. Let's move to question number 7, and let me read the question from the book. Question 7 says, the figure shows the metal framework in which AD is horizontal with BD. AD is horizontal with BD 7.1 meters, and angle BAD is 25 degrees, and angle BD and C is 46 degrees, and angle DBC is 103 degrees, and the height of B above AD is 5.3 meters, and then we have to find the length of the metal bar AB, angle that BD makes with BN. Okay, BD makes with BN. This is unknown. Okay, and then the length of the metal bar CD. These three are the unknown of this question. And if we look at the diagram which is given in the question, we can see that there is the presence of 90-degree angle at this place at the vertex N. So if it is 90 degree, this remaining part of the angle will also be 90 degree measure. Okay, you can see that the question is consisting of multiple diagrams in which triangle BAN is a right angle triangle, triangle BND is right angle triangle, and triangle CBD is an oblique triangle. So in order to find unknown in different parts of this question and diagram, we have to prefer to use appropriate techniques and formulas. This is also really important. So let's move to the solution of the question. First requirement of the question is length of the metal bar AB. Okay, if we look at the length of the metal bar AB, that is the part of the triangle BAN, and if we look at the triangle BAN, that is the right angle triangle in which we are given with two angles. One is 90 degrees, one is 25 degrees, and the one side is given 5.3. So preferably we will be using basic trigonometric ratios to find the unknown of this question. So let's move to the solution of this question, and it's really good to make small sketches before going to the solution. So I'm making the triangle, which triangle? BAN. This triangle, here we have a 90-degree angle. This side is 5.3. This angle is 25 degrees, and we need to find this opposite side, that is a BN side. Okay, let BN equals to, we can mark it with small n. Now recall basic trigonometric ratios that with the reference of this acute angle 5.3 is opposite and AB is hypotenuse. Now which trigonometric ratio we can apply by using opposite and hypotenuse? So that is sine. So in triangle BAN, okay, opposite upon hypotenuse 5.3 upon AB equals to sine 25 degrees. Okay, and let me check the value of sine 25 with calculator. and this is 0.4226. 0.4226, okay, and 5.3 upon AB. Now what we have to do, we have to shift this AB to other side. 5.3 equals to 0.4226 into AB, and now shift or divide 5.3 by 0.4226, and this will give me AB. 5.3 divided by 0.4226, 5.3 divided by 0.4226, 12.54. This gives me 12.54. So 12.5 equals to AB, or AB is 12.5, and measurements are in meters, so I have to write the unit meters, and then I have to block this answer so that my students can see this value carefully. Okay, now the second part of the question is the angle that BD makes with BN. Angle that BD makes with BN. So we have to find, this is the place where BD is making the angle with BN. Okay, now for the second part, what I have to do, I have to take a triangle BND, make the triangle here. Always support your working with small statement and reference figures so that examiner can understand your working easily, especially in form of the composite and multiple diagrams. So B and D, this BD side which is given in the question is 7.1, and this is 5.3, and we have to find out this angle that BD makes with BN. Now look, with the reference of angle B, okay, what is the relationship of 5.3 and 7.1? 5.3 is adjacent and 7.5 is hypotenuse. So recall which trigonometric ratio we can apply: adjacent upon hypotenuse. So cos B equals to 5.3 upon 7.1. Okay, cos B equals to divide 5.3 by 7.1, 5.3 divided by 7.1, and this gives me 0.7464. and then in order to get value of angle B, what we have to do, we have to take cos inverse of 0.7464. okay, shift and then press cos, and it will give you cos inverse 0.7464 and close the bracket, and this gives me angle B equals to 41.72. so angle B equals to 41.7 degrees. I hope you are clear about this working, and let me block this answer first, and then I will be moving to the last requirement of the question, and that is that the length of the metal bar CD. Now look at the diagram which is given in the question. In this diagram you can see the requirement CD is in the triangle BCD, and see what type of triangle BCD is. It's not a right angle triangle. So in order to find BCD, we cannot apply basic trigonometric ratios or Pythagoras. We will be preferably using sine law or cosine law, but cosine law we have not studied yet, so I will be preferring sine law here. First of all, it's good to sketch the diagram at this place, small diagram. This is BC and D. Okay, let me hold the ruler so that my students will also use and draw neat diagrams. Okay, and let me make it this side as well perfect. Okay, B, C and D, B, C and D. At this vertex we have the angle of Meyer 46 degrees, and over here we have angle 103 degrees. If I want to find this third angle, I can easily find it out by subtracting the sum 103 plus 46, and this gives me 149 minus 180, and this gives me 31 degrees. This angle is of Meyer 31 degrees. Now this is the face opposite to vertex B. This is unknown, and we have this side as well. So in triangle BCD, in triangle B, C and D, okay, B upon sine of B, B upon sine B equals to 7.1 upon sine 31 degrees, 7.1 upon sine 31 degrees. Now check value of sine 31 degrees. Sine 31 degrees gives me 0.5150, 0.5150, and this is 103. B upon sine 103 equals to 7.1 upon sine 31, and this is 0.5150, and this is B. Sine 103 sine 103 gives me 0.9743, 0.9744, and now in order to get B, I have to shift this denominator to other side, and equation will take the form 7.1 multiplied by 0.9744 upon 0.5150. okay, 7.1 multiplied by 0.9744, this gives me 6.91824 upon 0.5150. Now divide it finally, 0.5150, and B equals to 13.43. okay, and the measurement is in centimeters, so B, which is actually CD, equals to 13.4 and meters. I hope you are clear about today's lesson. For our next difficulty level, please catch me in the next class. Watch my lessons, like, share and subscribe the channel, and press bell icon to get the notification of every lesson in time. Thank you very much.